So what if you have choices of more than one structure? Which one is more acceptable? We are going to discuss that. So if I give you this total number of atoms, they want to make a bond, and somebody doesn't follow the rule of placing least electronegative atom, placing the least electronegative atom in center. So hydrogen can never be a central atom. Why? Remember we said hydrogen can only make one bond because it has one single electron. Hydrogen can never be central atom. If hydrogen is a central atom, it must make two bonds, right? To be able to see central atom. So this is not an option. See, this hydrogen is making two bonds. This hydrogen is making two bonds. It's not possible. Hydrogen always makes one bond. Why? It has one single electron which is going to share. So hydrogen cannot be central atom, but somebody doesn't follow the rule of minimum electronegativity atom to go in center. If you follow the rule, you see hydrogen is not an option between carbon, which has electronegativity of 2.5, and oxygen, which has electronegativity of 3.5. Carbon should go in center, and this should be the structure. But somebody starts with this, the one on the left. Let's see why the one on the left is less acceptable. Well, I'm going to define a rule which is called formal charge rule. I give you a formula. For every atom inside the molecule, we can calculate a charge. That charge is called formal charge. How do we do that? In order to calculate formal charge of an atom in a Lewis structure, we write total number of valence electrons in the free atom, the same way that you know total number of valence electron of carbon is 4, Y is in group 4A. Total number of valence electron in carbon is 6, Y is 6A. Total number of valence electron of hydrogen is 1 because it's in group 1A. So write total number of valence electron on each atom in a formula, each atom at a time. Next, write total number of non-bonding electrons. What are non-bonding electrons? Those are lone pairs, unshared electrons. Minus half of the total number of bonding electrons. What are bonding electrons? These are bonding electrons. Electrons which have been shared and make a bond. That's how you calculate formal charge. And don't worry, you may get kind of confused when you look at the formula. It's not that difficult. You practice, and by practicing, it becomes really easy. So when you calculate formal charges of each atom in a molecule, if you add them together, if there is no charge on the molecule, it must be 0. If there is a charge on the molecule, like we gave you example of CO3 minus 2. When you add all the formal charges, they must add up to the charge of the ion. This is an ion because it has a charge. So I'm going to go to next step. Suppose the students who thought this might be the formula, let's complete the octet and see if there is a formal charge. And molecules don't like formal charge. Let me give you an example. Suppose you're buying Christmas present for a loved one. And you have, let's say, $20 in your pocket, and you want to buy a watch for the loved one. You go to, let's say, to Macy's. You find the watch that you like. It's $30. Then you have to use your credit card to put $10 on your credit card. And before you buy the watch, you say, I'm going to shop around. Why don't I go check the Walmart? You go to Walmart and you see the same watch is $20. So you don't have to use your credit card. You don't have to charge $10 to your credit card. Which one are you going to choose? Obviously, the one which you don't have to charge. Obviously, the one that you can buy without putting any charge on your credit card. Add-ons do the same thing. If there is a forward charge, they don't love charging their credit card. No charge is better than charge. A formula which has charge is unstable. Why? Because charges either attract or repel each other. That brings extra instability. No charge means neutral, no repulsion, and no movement of the charge. So as a rule, if you write a structure where atoms have charge and you have an option when there is no charge, choose the one which there is no charge. That's all I'm trying to say. So this is the case where you're putting carbon and oxygen both in center. You have complete octet for oxygen, 4 on the left, 2 on the right, 2 on the top, that's 8. Do I have complete octet for carbon? 4 on the right, 2 on the left, 6, 2 on the top, 8. Yes. Hydrogen are happy with 2 electrons. So this is a plausible structure. But let's see, how many electrons have we used? 4 electrons. But how many electrons atoms are bringing? Carbon bringing 4 electrons. Oxygen in group, see this is in group 4A. Oxygen is group 6A, bringing 6 valence electrons. Hydrogen is in group 1A, it brings in 1 valence electron times 2, which adds up to be 2. If you add these together, total number of valence electrons is 12. And when we wrote this structure, how many electrons are we using? Is this a valid structure? Where can I say I have 2 single bond and 2 single bond is using 4 electrons? Can I say I have 1 double bond? Every double bond means 4 electrons. Can I say I have 2 lone pairs? Each lone pair are 2. 4, so total number of valence electron used is 12. Total number of valence electron which brought in is 12. So according to Lewis structure, this is not invalid structure according to the 5 rules. How about the charge? We will check that later. Now, if I go to calculate the charge, I can do this formula for each atom. So let's calculate the charge on carbon. Total number of valence electron in atom of carbon is what? Is it in group 4A? So that's 4. Minus total number of non-bonding electron on atom of carbon. Do you see 2? Minus half of total number of bonding electrons. On carbon, look at the bonding electron. Can I say 2 electrons in this bond and 4 electrons in this bond? Because there are double bonds. So should I write half of 6? 3 bonds make 6 electrons. If I calculate, I get -1. That means there is actually a formal charge on this structure. Those are the 3 bonds on carbon. So there is a negative bond that is called formal charge. How about oxygen? Total number of valence electrons in free atom of oxygen. Is it 6 because oxygen is in group 6A? Minus total number of non-bonding electrons. How many non-bonding electrons do you see on oxygen here? You see 2. Minus half of total number of bonding electrons. How many bonding electrons do you see on oxygen? Is there 4 electrons for one double bond? 2 electrons for one single bond. These are bonding electrons. So I write half of 6. So you get +1. That means in this particular structure, you have a negative 4 mole charge on carbon and a +1 for oxygen. So there is 4 mole charge here. So if I have another alternative, which there is no 4 mole charge, that's more acceptable than this one. So I'm going to go to the option where carbon with a smaller electronegativity is placed in center. Oxygen, which has more electronegativity, is bonded to central atom carbon. Hydrogens, which can never be an atom in center. Hydrogen makes 1 bond. Hydrogens are always terminal. So let's investigate if there is any 4 mole charge in this structure. If this doesn't have 4 mole charge, this is a better structure than previous one. Let's check. Total number of electrons remain the same. 4 from carbon, 6 from oxygen, and 2 hydrogens bring 2. So 4 plus 6 is 10 plus 2 is 12. Total number of valence electrons is the same, 12. And then I'm going to determine 4 mole charge on the atoms. Let's start with 4 mole charge on carbon, the same way we did before. Total number of valence electron in free atom of carbon. Is it 4? Carbon is in 4A. Can I say there is 4 electrons in carbon? Minus total number of non-bonding on carbon. Do you see non-bonding on carbon? No, so 0. Minus half of the total number of bonding electrons on carbon. Look at bonding electrons. Is this bonding electrons 2? Is this bonding electron 4? Are there 4 electrons in the double bond? 4 plus 4 is 8. So minus half of the 8. You see total charge on carbon is 0. No charge on carbon. That's good so far. How about charge on oxygen? If that is also 0, this is a better structure. So let me erase this so you can see better. Oxygen, what is total number of valence electron in oxygen? What group oxygen belongs to? Is it 6A? Can I say 6 valence electrons in oxygen? Minus total number of non-bonding electrons in oxygen. Can I say there are 2 non-bonding electrons, 2 non-bonding electrons, a total of 4. So can I say non-bonding electrons are 4? Minus half of what? Half of total number of bonding electrons on oxygen. Do you see this is the only bonding electrons, 2 bonds holding carbon to oxygen? So should I write half of 4? 0, no charge on oxygen. So this is a better structure the same way that you have 2 options. $10 charge on your credit card if you buy it from Macy's. $0 on your credit card if you buy it from Walmart. Obviously you buy it from Walmart. Molecules do the same thing. They don't want to have charge. Charge means lack of stability. If you have a lot of charge on your credit card, is it fair to say that you are not very stable, you can't sleep at night? You're always worried if I'm going to get bankrupt, if I'm going to lose my credit. So molecules behave reasonably and logically. Okay, what does it mean? It means for neutron molecule, a Lewis structure in which there are no 4 mole charge is preferable. relative to the one which has charge. Next, if there is no choices, suppose in the example I gave you, the cost at Macy's is $10 on your credit card. At Walmart, the credit card charge is $5. That means, suppose there is a molecule which has to have formal charge. The one which has less formal charge is more acceptable. So if you don't have a choice, two possibilities, one of them has larger formal charge, the other one has smaller formal charge, choose the one which has a smaller formal charge. Wouldn't you rather to place $5 on your credit card instead of $10? Yes, molecules do the same thing. They will try to have minimum formal charge if there are two options. So among two molecules which have two options, they have same formal charge. The atom which is more electronegative will try to accept the negative charge. Now let me give you an example. Suppose you and your partner are going to buy this watch that we are talking about for your mother, and you don't see any possibilities, but you have to either place $10 or $5 on your credit card. Between the two of you, which is more financially responsible? That more financially responsible person says, let me put it on my credit card because I never lose the payment on time. I never end up paying. I don't get penalized. In other words, you know how between couples, one of them always forget to pay on time and you end up paying penalty, extra money. And there are some partners, they pay the charges on time and they make a good credit for you. So you want to say, honey, why don't you take care of these things? Because I seem to be forgetful. You are doing a good job. So you take care of charges. So the same thing, if there is negative charge and there is no other options, molecules place the negative charge over the more electronegative atom. Why? More electronegative atom love negative charge, they handle negative charge better than other atoms. Can I ask you to ask a question? If I have already confused you, would you go ahead and ask a question, please? Anybody? All right. So we are asking what is the more likely structure for CH2O, the one on the left or the one on the right? What would you say? Left or right? Left or right? Help me.
Right.
Good job. You are right.